Ladies and gentlemen, very warm welcome to the last session of this SafePASS webinar. This presentation is on the advanced risk model developed in SafePASS for the evacuation and abandonment process of people on board of passenger ships. This advanced risk model will be jointly presented by MSRC and DNV. Like any other activity, maritime transport inadvertently involves the probability of incidents and accidents, in other words, risks. These risks need to be reduced to an acceptable level by the ship design and operation. Typically, risk should be made as low as reasonably practical, allowable. Roughly speaking, in an ALAR process, the costs for the risk reduction are evaluated by means of this risk savings. Application of the ALAR principle requires risk assessment, which means quantification and evaluation of risk. Frameworks for assessing risks have been developed for the last 60 years. In nuclear industry, probabilistic risk assessment was introduced in the 60s. In the chemical industries, quantitative risk assessment in the 70s, and in offshore industries, quantitative risk assessment and the safety case in the 80s. Shipping industry followed with the formal safety assessment at the end of the 90s. It is worth noting that most of these developments were initiated by major accidents. What is risk? Risk is defined as a measure of the likelihood that an undesirable event occur together with a measure of the resulting consequence within a specified time. Briefly speaking, risk is equal to probability times consequence. Risk can be reduced either by reducing the probability or likelihood of occurrence of such accidents and incidents, or by reducing the consequences, which means minimizing the impact on persons on board. Typically, risk to person on board of a vessel materialize when the ship loses the capability of providing a safe place. In case of an accident, such as collision, contact, grounding, foundering, fire and explosion, people are either directly affected or need to leave the ship. In this case, the evacuation and abandonment process is crucial for the probability of survival. It is quite obvious that this process is very sensitive with respect to the accident scenario. For instance, flooding or fire development, the time for safely abandonment the ship, and ship conditions. For instance, time required for evacuation is expected to increase significantly with increasing ship movement, for instance, by rolling. In SafePASS, we are developing an advanced risk model that will describe the evacuation and abandonment process in a transparent and objectified way. It will help to identify the setting screws for risk mitigation, which are the screws for identifying risk mitigating measures, and provide the basis for specifying risk-based expected performance for IMO functional requirements. Such functional requirements shall describe the requirements in a technology-independent way, and by this being open for future development. This risk model in combination with ALAR can be used for calibrating the expected performance of such risk control options, which are providing the basis for requirements. The basis for the SafePASS risk model is shown by this generic event sequence, which was developed in the IMO discussion on the development of functional requirements for the alternative design for SOLAS Chapter 3. The sequence described main elements between the initial event, accident, and safe haven. Safe haven is understood as a place providing all needs and thus reaching another ship or a search and rescue unit is not always sufficient and cannot always be regarded as a safe haven. As shown, after the accident, we have a phase of where we are evaluating the situation, and the decision is made whether it's necessary to leave the ship. This is followed by the embarkation and LSR preparation and embarkation process. And finally, all people on board will abandon the ship, either by using the life rafts, MEF, or lifeboats, or by jumping into the sea. Subsequently, there is a phase which is named survival at sea, where people are waiting for rescue, which means until the arrival of search and rescue units or other ships, which will retrieve them from the sea and transport them to safe haven. This generic event sequence is the basis for the further the development of the advanced risk model in SafePASS.
Thank you, Dr. Hamann, and hello, everybody. On my section of this presentation, I will talk about our efforts as a research center towards utilizing the existing knowledge in the field of maritime risk analysis and trying to update and extend it beyond its current status. So far, the risk models were focusing primarily on the analysis of the events that led to an accident and the consequences up to the point of mastery, whereas the abandonment, clearing off, and waiting for rescue stages were dealt with, let's say, less scientific sophistication and approaches. This is also reflected by the existing evacuation performance regulations. Our work in SafePASS is directed on the detailed investigation of all stages, from alarm to rescue, and sheds some light on the hazards and risks that are associated with the critical stages of LSA launching and waiting for rescue. Our first step was the creation of an up-to-date database with a unique taxonomy, which could showcase and bring out those particularities of the aforementioned critical stages from alarm to rescue. This was a laborious process performed in collaboration with a team from NTUA and included looking over the accident reports of various accident types for large passenger vessels over the past 20 years. The result of this fusion of information was a database that allowed us to identify evacuation-related critical parameters and perform a statistical analysis based on this data. It essentially gave us the means to quantify several risk variables and guide us towards those risk areas that could play a key role in the estimation of potential fatalities. On the left-hand side of this slide, you see a selective few output examples from the qualitative and statistical analysis of the SafePASS accident database. More specifically, you are looking at the annual accident occurrence for ROPAX and cruise vessels, the geographical distribution of the accidents, the natural light during the accident, details about the damage location, position, extent that could be associated with the damage assessment, and of course the number of fatalities depending on the vessel type. From there, and based on the existing literature on this specialized corner of maritime research, we were in a position to draw a series of influence diagrams for each variable of the evacuation process problem. Finally, we transferred those critical variables to a decision tree. We placed them in a sequential order, created for each decision gate the relevant branches, and came up with the backbone of the risk modeling tool, which will be explained later on. Each node of these tree corresponds to an influence diagram, and the database, data and failure rates, and existing models regulate the probability distribution on each decision gate. At the same time, those influence diagrams, due to their parametric structure, allow for dynamic risk modeling. I hope you found this part of the presentation intriguing, and I will leave you now to Professor Boulogouris, who will take over from here.
Thank you very much, Fotios. I will now present to you the risk modeling tool. The SafePASS risk modeling tool will use the developed research backbone in order to provide a reliable estimation of the potential loss of life. The tool will be able to support risk-based design approaches. It will assist the designer to make risk-informed decisions for the arrangement of the ship. It will also help the operator adopting the appropriate procedures for the particular ship, minimizing the risk in various emergency scenarios. Most importantly, the risk modeling tool will provide decision support in real-time emergencies. It will integrate existing numerical simulation tools such as Proteus for flooding or FDS for fires, and create a knowledge database of evacuation and abandonment scenarios for a given ship. It will be able to continuously assess the potential fatalities on the various branches of the event risk, based on live input from users, sensors, and other SafePASS components. The main building blocks of the SafePASS modeling tool are shown on the left-hand side of this slide. The first one is the artificial intelligence toolbox, where the input from the sensors is combined with a knowledge database and an ultra-fast pathfinding tool. Deep learning algorithms are used for a forensic filtering of the data and identification of the appropriate scenarios. In the second block, based on the fault tree and the accident type, a dynamic evacuation tree is formed. In the third block, the time available, for example, the time to capsize, is compared with the time to evacuate, and potential loss of life is estimated. On the right-hand side, you may see the flow of information between the event tree gates, the influence diagrams, and the other SafePASS components. Providing decision support in emergencies requires proper communication of the available information to the decision makers. This is why the risk estimates produced by the tool and the most important parameters will be presented in a dashboard similar to the one shown on this slide. The colors, the data, the font selected, and the different screens available will be designed having in mind ergonomics for the optimum human-computer interfaces. The end user's feedback will be taken on board in order to finalize the design of the risk modeling tool's graphic user interface. Summarizing our presentation, in SafePASS, we have created an up-to-date large passenger ship accident database with a new taxonomy that incorporates all the parameters affecting the evacuation and abandonment process. This facilitates the identification of the factors influencing the potential loss of life at each stage and allows to create inventories for the real-time calculation of the fatalities. A risk modeling tool is utilizing this novel risk model to fuse all the available data and support decision-making during emergencies. Here, I would like to thank you very much on behalf of all presenters this presentation, and we would be very happy to answer to your questions. Thank you very much.